Hey everybody, Rich Everts here with Lancaster AI. It is the last Tuesday of the month, right after Memorial Day here in 2020, and I am excited today to talk to you a little bit about some Lancaster AI stuff, some things that are happening with XNOR and Apple, and really a lot of businessy kind of stuff. And it's a neat time to be in this industry. So I know last month we kind of delved into a little bit of the reasons why AI is kind of failing in a lot of businesses and what are some of the bad points really about AI businesses these days. But today we're going to talk about some of the good stuff. And so with that, it's good to see everybody, and feel free if you have any questions, just hit up the tab bar here and I'll answer whatever we have in the live chat. And so let's get it kicked off here. So as you can see here, this is the Lancaster AI page, and today we're going to talk about XNOR.ai, and Apple purchased them back in January. They really kept it low on the radar. They actually purchased it through a shell company and all this other stuff to get it running, which was interesting, and it was a $200 million deal. And this was a really, really big deal, and it showcased a lot of where Apple is going. Now, a lot of companies out there, they'll say things like, I don't know, they'll say, oh, we're going to do this kind of special stuff with AI, we're going to do cloud-based, we're going to do this, and some people don't listen to them too much, but when a company as big as Apple does something, people listen, people wake up. I don't know if it's still the largest company in the world, but it's one of the top ones, depending on how the stock fluctuates and everything like that. So, where did Apple kind of start this whole process? Well, some things you got to remember about Apple in case people aren't following them. I don't follow them a ton right now, not as much as I used to. I used to work with an Apple reseller, and I used to repair Macs, and I used to do a ton of stuff with Apple, and I've always been a big fan for, gosh, ever since I was little, so almost 35, 40 years now, so it's been a while. But what I want to show you here is, in 2020, Apple attended the CES, so the Consumer Electronics Show, for the first time in almost 28 years. So I believe that's what the deal was. And it was a very big deal. Why would they go to CES? And so they wanted to talk about the HomeKit and what they were doing with HomeKit. And this is it's a very different way of handling home automation, because it's actually serving as a home hub almost. And they went to CES, and this is Jane Horvath, maybe, I'm not sure. She's a person who's been running Apple's privacy officer, and she actually gave a special talk. She was on an all-women's panel there. And they talked a little bit about the CES challenges that they had with privacy, the FBI challenges that they had with privacy, and she talked about where Apple is going with that, and why they're trying to secure the data, and why they try to not create backdoors. And you can say a lot about Apple. There's a lot to pick apart, a lot of challenges here. I think this is one of their strong points, and one of the things I really like about the company, and where Tim Cook has really positioned it, is this stance on privacy. I think it's very important moving forward. Now, let's talk about this purchase of XNOR. So what the heck is XNOR? So XNOR.ai was an edge AI spinout from Paul Allen. You remember the late Paul Allen? So he started an AI institute up in Seattle. This is actually, I think, the second company of theirs that got purchased. And this one was for 200 mil. Which doesn't seem like a lot in the grand scheme of things when you think something like WhatsApp got bought for $16 billion, but they did pretty well. So they had 3 main people here, so that's a nice chunk of money split between a few people. And so if you look at this, you can actually see in the center here, you can see one of their devices. And what XNOR really did is they create AI-specific hardware using FPGAs, but they create customized neural network models to work on those. And so one of the things that XNOR really did amazingly, this one right here, if you read it, they created a chip that can use solar-powered AI to do object detection. Now, any of you who've done any kind of inferencing on deep learning models know that it requires a lot of power often. So when you're dealing with training, for instance, we know that multi-GPUs or TPUs, we send them off to the cloud, or we do all kinds of different ways to train them. I like local training on, NVIDIA SLI setup and all those kind of things. But you're using a lot of power, a ton of power. And then inferencing even requires a ton of power. And that is one of the drawbacks to putting it in edge devices. Because even when if you want to, for instance, put it on a drone, one of the things that you're always offsetting when you're building drones is how much weight you have to put on for the fans versus how big the battery is, and so you're balancing that performance for flight time. And so when you're dealing with AI, well, if you have to have a Jetson Nano or something like that up on there with a camera, you're going to suck down that power a lot faster. And so having something that can actually run on solar power and do object detection, it's huge. And in fact, we're going to take a look at the paper here in a little bit, but to give you the exact performance. But we're talking orders of magnitude better performance on a little CPU. Forget GPUs. NVIDIA should be scared right now about what is coming out here and what people are building. Okay, so that's the first thing that XNOR did. They really have this specialized AI for different kinds of CPU-based FPGAs. Now, interestingly, most people don't know, but Apple is one of the largest purchasers right now of AI-based companies. I mean, look at how many we've got here. And you can see Google's second, Microsoft, Facebook, and Amazon, right? So it's the FANG companies minus Netflix. So this is what you would expect, right? So the big Silicon Valley companies are going in and grabbing these. And, okay, so Apple is the big one there. Okay, interesting. But what does that mean? Now remember, I wasn't down on AI last month, but I was definitely pushing back a little bit against the idea that AI businesses are the thing. Like, you can't walk into a VC's office anymore and say, I'm building an AI this, and they'll give you a check for $500,000. And those days are kind of gone for most people, okay? You have to show some of the things. And so what does that mean for actually building a new kind of AI business, right? Well, so one of the things that Andreessen Horowitz, which we talked about last month, right? You have gross margins. So I actually took some notes on this exact part here. So a lot of companies believe that you can create a better neural network and you can create a different kind of service. But the thing is that Andreessen Horowitz was saying that that's not going to work, because even with a better neural network, even for an extra 5% on your mean accurate precision or something like that, is not going to be enough to differentiate you between all the other competitors out there. And so what ends up happening is, especially if you use AI as a microservice, so for instance, you send it off to, a company sends off something for NLP, sentiment analysis, right? Well, you're going to end up having to spend a lot of money to train those, to put humans in the loop. People highly underestimate how much human behind-the-scenes action has to happen to make AI systems work. And they just don't scale very well. And a lot of people are starting to figure this out. Andreessen Horowitz really spoke about this. And I think that's one of the things that you can see here in Apple's purchase of XNOR, and why there is this shift really happening, is you're looking at systems engineering that's building a special sauce, right? And that's something that they talked about here. And this is human in the loop. Scaling is tough. And we talk about building and scaling, and like how do we do that? So choose a problem domain carefully and narrowly to reduce the data complexity. Focus on something very specific and be very, very good at it. And this is a way to build defensibility in the old-fashioned way. So this systems engineering, this special kind of engineering, could actually serve as a template, so to speak, moving forward. Okay? So how does this compare to some of the other companies and where they're going? So this is why XNOR is a different kind of purchase, and it's very different than you're going to run into in a lot of the AI purchases out there. So let me show you what I mean. So let's look at Google AI, their system. So Google purchased Next right back in 2017. They're kind of in this in-between where they shut down the Nest API, and it's a mess. I don't want to get into that right now. I've been working on a project for that. But the Nest Cam IQ Indoor, really what you're doing is that you're getting the information, your pictures from wherever it is in your house, sending it off to the Google Cloud. It performs the object detection, then sends it back to an app, which usually you have on your mobile phone, and you can get alerts. It does facial recognition and all those kind of things. But in order to make these work, it runs off a USB-C connection, which runs into a plug. And then the transformer, obviously sends all the power that you need there. And it sends it back to, operates through your Wi-Fi and then sends it up to the cloud. But there's not enough computing power in here to actually run the object detection. So you get some latency in there, which is one big issue. The other thing is that, hey, anybody can be watching this. Even with end-to-end encryption, it is tough to guarantee that this will work well, okay? There's all kinds of stories out there about Nests and all those things getting hacked. Now, usually it's because of password errors, but it is open to be hacked. And so that's why people want to get off the cloud, because you have to reduce the threat vectors of people coming in order to make your product better. That's what it's all about. You can't make a perfect product, but if you can reduce the threat vectors, you can at least make your defense manageable. Okay, that's Defense 101, okay? And here, Google Nest has left themselves open for this. Now here's another one, Wise. Now these are budget cameras that a lot of people have been very into. And these guys right here, the Wise Cam and the Wise Cam Pan, $30 and $20. Whew! You can send it up the cloud, do object detection, right? All that stuff. And they did it dirt cheap. Well, guess what? Apple's acquisition of XNOR basically screwed them over, because now they can't do cheap object detection. Now, I wouldn't use a Wise camera. I wouldn't trust, not that Wise is a bad company, because they are not. I think the people at Wise are great and they're trying to do good work. I think right now for their particular product and what this is, it's not going to work, okay? Because they've lost the object detection. They've lost being able to push it out to the cloud and perform that and then send it back. So in essence, they have these cheap $20 Raspberry Pi cameras that they're putting around the home that are streaming data. Okay, so that's really where a lot of these places are going, especially if you look at CES. Everybody wants a mobile app, and everybody wants that kind of information in the cloud because they think they have control over it, and it's easier for them to scale. But that's not where Apple is going. Apple's going in a different direction. I think it's the right direction, because that's what I'm doing in the work that I do. So let me show you a little bit more about what the white papers are. Now, I know I'm not going to go through it all in detail, but there's a couple of big white papers here. So this is XNOR.net, image classification using binary convolutional neural networks. So you might realize, see, this is the Allen Institute for AI. That's where XNOR came from, right? And then many of you might notice Joseph Redman. That's actually P.J. Reddy. That's the guy who created YOLO neural networks, which is the most commonly used neural networks. Now, he left that behind because he said he's not producing any more YOLOs because they're being used for things that he's very upset about. And so he doesn't want to participate in it anymore. And, when it's being used for mass surveillance, you do have to question what you're building and what you're doing. And I give him props for that. So here's what they found, though. This was published in 2016. I'll include the link in the video on YouTube later. So in essence, what they're doing is they're taking their weights and they're what's called binarizing. I think that's how you're pronouncing it. So it's -1 or 1 or 0, right? And so there's a lot of ways to do this. Here's the performance that they found. So when they use the XNOR, in terms of the memory of the size of the the model, right? So when you load a model, you have to load it into memory for inferencing. So if you have a Jetson Nano and you load it into there, you might have a gigabyte or a couple 100 gigabytes of data, or sorry, megabytes of data, and the memory saving is 32 times less space. 32 times. Now, when you're using less memory, that also means less access, which means less voltages having to run across your system, so requiring less power. And then check this out, computation saving, 58 times more efficient. And that was just in this one back in 2016. 58 times more efficient. All right, we're going to take a look at that. So I'm not going to deal with this too much, but these are the way that you've heard of these solutions being proposed. Okay, so you have shallow networks, so that's reducing the number of hidden layers in your neural network. Okay, easy. Compressing deep train networks. Now, this is what NVIDIA does in a lot of their deep streaming. If you notice the deep streaming SDK, if you've ever looked at that for video analysis, that's mostly, they use a ResNet 18 neural network with massive pruning using uint8 accuracy. So instead of using uint32 or uint16, I think it's uint8. So they shorten it, and then they prune it and do all of these things. That's how they're able to do all of these full HD camera scans. They can do up to 8 of them on a Jetson Nano. Well, that's basically because you're just hardly doing any computation. You're like rubbing a piece of paper over the darn thing because the accuracy is way low. But that's what you can do. That's one way that you can speed it up. You can compress a pre-trained deep network. You can redesign the layers. So, you usually have batch norm, and then you have your convolution, and then you have some you don't necessarily have pooling all the time anymore, but you have that on a compact layer, right? And then you can change the parameters, all kinds of things here. So I'm not going to get into all of it here. And if you want, you can go into the actual convolution to figure out how they estimate these binary weights. And really, the optimal estimation of binary weight filter can simply be achieved by taking the sign of weight values. So negative, positive, and the optimal scaling factor is the average of absolute weight values. Okay? So they talk about how they train it. They actually train it using these binary weights. So that's important for them. They train it with that. And then you can go through and take a look at these networks, and they break it down here about how they break them. They actually do the training. You can reproduce this. So this is a typical block in a CNN. And you can see in the image behind me here, this is the YOLO V3 network, and I kind of combined these different steps. But if you've worked in neural networks, you can kind of look at this. So a typical block, so you have your convolution, you have your batch norm, any activations, and then your pool. So what they do is they do a batch norm, then they do the binary activation, the binary convolution afterwards, and then the pool. So it is a little bit different in how they run it. But here's what they found. I mean, check this out. Maybe I can make this bigger for you. So on VGG19, which nobody uses, okay, it's just nobody uses that anymore. But instead of using 1 gigabyte of memory, it uses 16 megs. ResNet 18 was 1.5 megabytes. I mean, 1.5 megabytes, you might even be able to fit that on an Arduino, for Pete's sake. And even AlexNet, 475 down to 7.4. Now, one of the things that you notice here is that this is a logarithmic scale. So they go 32 to 1024, notice that. But there is a flattening of the curve here. And it seems like 32 is probably where you get the largest slope, would be my guess, before it starts to peter out here. So, and in here, filter size somewhere around 3355 maybe. So it does matter in the scaling, but probably not as much as you think here. And then their results, they take a look at it. So here's their results, their classification accuracy. So with full precision, a top one would be around 56.66 and 80.2. They're around 69.2, okay, and 44.2. But this is with, like I said, 58 times better performance, and you're getting a 44.2 on the top versus a 46.6, which is pretty darn good. Like, if you don't need super precision, you're okay. So, and then we do a comparison here, obviously, of ResNet. Look how it compares to ResNet. We're talking pretty comparable, and it's fairly close. And that's good because ResNet is a standard in a lot of these areas. Okay. So I'm going to put this link in here. Check this out. This is great work. Now, if you're interested more in finding out about how the hardware and the future of where these things are going. So AI is moving into these embedded devices. I guarantee the military has looked at this up and down about how to hardware optimize their networks. Okay? And all kinds of people, and I say the military because they're generally cutting edge, and a lot of these, you go to DARPA and some other places, they're putting money into these. Now, there is definitely some R&D, like some skunk works kind of stuff going on at Google, Apple, and the typical FANG companies, absolutely. Even they don't have the resources often that the military has. But in this particular instance, you can see that a lot of these people are all going in this direction. So, this hardware here. So here's the actual architecture. Now, if you're a hardware person, this will make sense to you. I'm not particularly a hardware person, but I do understand a little bit of what's going on here. So you have stuff coming into the input buffers. You have your shared memory registers. And here, when you convolve the kernel, you're ended up storing a copy of it. And then it goes through the convolution and then sends it back into here, gets combined, and then you move on. Okay? But they actually lay it out in this paper about how to handle these FPGAs. And what they found here, I'm sorry, I'm scrolling through, optimization flow, let's get in here, okay. Design, here's what I'm looking at. Yeah, there it is, sorry. I know that scrolling is kind of frustrating. So here's this particular group's algorithm evaluation of 4. So you have an x86, so you got an i7 versus an ARM v7, and then you have a little Zinc, ZYNQ, and then a GPU, of course, the Titan X. Okay, so look at these. So you have a 3.7 gigahertz on a 45 nanometer. You have a 1 gigahertz on a 28. You have a little 200 megahertz. 200 megahertz. This is like Pentium 2 speeds back in, you know, the 90s. Okay, that's what we're talking about here. Now, of course, it's 24 nanometers, so it's a little bit different. Got it. Okay, but then you have your GPU. Running at 1.5 gigahertz, and it's running CUDA, and it's optimized for floating point operations. So this is your beast in the block. And so what we find here, so YOLO, okay, here we're looking at 0.003 seconds, right? So 3/1000th of a second for a tiny YOLO. So it's a lot of speed. Okay, so here's 1/100th. So you can get 100 frames per second on the GoogleNet YOLO version on a Titan. Okay, 100 frames per second. Now this one you can get 3/4 of a frame per, or 1.5 frames per second. But look at this. Look at the power consumption. 230 watts versus 1.167 watts. Okay. That's a lot less. That's barely a hum on this. Now, you're not getting full real time on here. You could probably need to speed it up there, and your power consumption would probably need to go up. But you could get general real-time performance on something probably running somewhere between 600 and 800 megahertz and not have to use too much power. And this is pretty impressive. It is really impressive where things are going. So I have about 5 minutes left here. So I just want to let you know that this is some of the stuff that I was talking about back in 2017 and 18, some of the things that we were working on at Sugey One. Many of you know that I'm the CEO, co-founder over at Sugey One, and we do a lot of this kind of work, and we're working towards this. And I've put my money where my mouth is. I truly believe that this is the future, and I think where Apple is going, I think where XNOR was working, and where we're working is all in the same area. I think ultimately, you need to build something with privacy built into the infrastructure of your system's architecture. Okay, privacy is not something you slap on, it's part of the architecture. And so that's why I'm really excited about what XNOR has done here. I'm excited about what we're doing because I think what we're doing will appeal to many companies and customers out there who are really looking at and saying, hey, we want better privacy, we want better efficiency, and we're willing to do whatever we can to pay for that and make that happen. So with that, thank you for coming out. And I appreciate it, and looking forward to catching up with you here in a little bit. So I'm going to get over to the questions now. All right? Thanks. All right, what do we got here? Grant, why is the sky blue, Grant? I think it has something have to do with the refraction of the electromagnetic waves in the blue area of the spectrum, which is that high wavelengths? Closer wavelengths? It's been a while since I've looked at EM field labels, but I think that's why it is, because we're refracting those EM wavelengths. Okay. So, YOLO is not living anymore. No, actually, YOLO is dead. And YOLO v4 has been picked up by other people, but Redmond is not part of it. So other people have kind of picked it up and run with it, but YOLO itself by Mr. Redmond, PJ Reddy, is dead, as far as he says. Now, and he just made, I think he made a bunch of money. I think he was part of that deal. So he probably got some stock and stuff like that in XNOR. So my guess is he's doing okay. All right, what other kind of questions do we got out there? No problem. No problem, Claire. Anybody else have any questions about XNOR, about Apple, about where AI is going? Anything along those lines? Mm-hmm. All right, well, so I found a PCI FPGA by Intel. Yep, I've seen that. Could this replace GPUs on the server? So the FPGAs are tied into very specific kinds of operations. So they're building an FPGA specifically for object detection. And so that's kind of where the future is going to be, is FPGAs for specific tasks. Okay, it's not going to be for just overall generic performance. If you just want overall generic performance, you still have to go with the GPU for training and stuff. All right, well, I appreciate everybody coming out. I'm really excited. I was glad to share this with you, and I'm really excited about XNOR and what they accomplished and where Apple is going. I think they're in the right direction. Again, if anybody wants to chat, anybody wants to talk, you know where to connect with me. Go ahead and find me on the Lancaster Amish Tech. You can go to lancastertech.com. You can go find us on Slack at Amish Tech. In Slack, I forget. I'll put the link in the setup, and that should be it. So I'll see everybody later. I hope you had an awesome May, and June is going to be even better. Looking forward to it. And I'll see you next time.